All right, onward and upward with the OSD Island Marathon here with Scrub and Repair. All right, Sam, you get to keep going. 2 hours of straight talking.
Okay, for anyone who attended the Giant or Firefly, or perhaps even Emperor CDSs, this one will seem familiar, which is the Scrub and Repair blueprint. Namely, we would like there to be a Redis interface where you can find out stuff about the repair state of a PG. The main driver for this is less that you'd use it directly and more that we'd use it to build a more smarter repair tool. At first, simply a command line utility where you could query which thing is inconsistent and how about a PG, and then make a decision about what to do about it. So the interface, if I recall correctly, has a couple of pieces. One is you need to know which PGs are inconsistent, and you need to do it in a way that doesn't require enumerating all PGs at once. So there's a last pager that you can use to. Oh, that was a mistake. Anyway, so this interface should also have a next PG pointer in case out is empty for get inconsistent PGs. Next is a way to query information about the inconsistent PG. The activation epoch is useful because the information we keep on inconsistency we may not want to persist across epochs or across interval changes, or maybe we will. It's hard to say. In which case, if the activation epoch is after, you would get back something like E again, and you'd have to scrub it again before the information was up to date. Aside from that, it just gives you information about which objects are inconsistent, so that you can then feed them to. And at the bottom, there's an listed inconsistency information with an undefined inconsistent info t, which probably has something like a bool data is inconsistent or a thing metadata is inconsistent, and then a list of the relevant fields and checksums from all of the replicas. Then you can use repair inconsistent object with the PGT to repair that you used above. The activation epoch, so again, if it changed, you know. And a replica to use to do the repair. This interface doesn't extend super well to erasure-coded PGs because replica to use is less helpful. But on the other hand, this should almost never be necessary for an erasure-coded PG. So maybe, I don't know, maybe the answer is something like mark replica unreliable or something for this object. And then once you've done that to enough, to all of the ones that don't agree, the OSD then fixes it. That would actually work for an erasure-coded object.
So in the pad, I pasted in the notes from the Hammer session, where I believe we broke it down reasonably well as far as the actual steps that we need to do.
Yeah. I mean, the first step is that kind of the way we do scrub needs to be restructured so that we write the information out somewhere useful. Yeah. We probably write it out using repops to an internal object, which is easy. Yep.
Does it need to be a replicated object? Because the way it was proposed, it would be discarded when peering happens.
It doesn't have to be. So those are the two options. It's probably simpler to write it to a replicated object and then just treat it like any other object, like we do the OMAP. Actually, it's not a replicated object.
Or not the anyway. Like the hit sets. Put it in that.
So treat this. So when this first was a thing, I think it was prior to hit sets. So we didn't have sort of repop created internal objects. So we could do this like hit sets and make them first class Redis objects, or 1.5 class Redis objects. Or we can make them like the OMAP thing where it's a per OSD maintained lookaside index and not choose to maintain it across peering intervals. The former does have the advantage of being able to remove the activation epoch part. It does complicate PG split very, very slightly, in that we'd have to read it and split it.
It could be discarded on split.
It could be discarded on split, in which case we would need to use the activation epoch for E again.
Yeah.
So this can't, I think, be defined much more until we actually start working on it. That's probably the reason why so little has happened on this one. It's hard to define exactly because it's the first 4 person weeks are just restructuring the existing code until something like this can even fit. Anyway, does anyone have any? Go ahead.
Does that much restructuring have to happen just to record the scrub errors that we find?
Probably not, but the way repair currently abuses recovery is insanely brittle.
Yeah, but that comes, repair part comes later. It's the first step would just be to store the scrub results.
So if part A is, yeah, okay. If we want to put off actually implementing the repair, we can do that too. That's actually what I mean is the hard part though, because repair has to be initiatable as a Liberatos started operation with some kind of completion time, which mixes the worlds of client I/O and recovery, which are currently asunder.
Mm-hmm.
I want to be careful about that.
Yeah.
Does anyone have any insight into sort of scrub and repair scenarios that this might not be expressive enough to cover?
If it's a replicated object that has the scrub results, if that has a problem, then you just have to throw it out probably and start over.
That's actually an even better reason to leave the E again option. That's true. I'm adding that to pad.
I think the other slightly useful piece here is that the third step on this list of just adding at Liberatos the ability to read a specific replica or shard. Surfacing that in Liberatos is sort of an enabling piece to being able to do client-side erasure code reads directly, if we ever do that.
Oh yeah, last time we had we discussed a bit about whether that would be a primary mediated read or not. Which way did we come down on that?
Well, this would be independent of scrub entirely.
I know.
The ability to a non-primary mediated read.
It seems to me that there's a difference. Well, I guess it works. Yeah, okay. If we add the appropriate locking to the replica side, which we need to do anyway, then it'll work.
Right. Which we need to,
Right, which means the read interface needs to be extended to allow you to actually specify the replica you want in a way that you need to be able to read from replica that isn't in the acting set too. That's sort of a problem.
That isn't, so he said?
Yeah.
When would that happen?
I guess you don't need to. Well, I was thinking if the current acting set had no valid copies, but no, that wouldn't ever happen. At least it would look different. It would look like an unfound object, not like an inconsistent object. Yeah, never mind. Well, okay, so an extension to this mechanism might allow you to read an object from a PG copy that has an obsolete copy and inject it back to repair an unfound object. But that's future work. I don't think we need to cover that here.
Yeah, I mean, I would assume that in order to make again, tangent, but in order to make the client-driven EC read work, when you do all the read shards, you'd look at the version that comes back in all of them, and only if they all match would you obviously do the decode and return the read.
Yeah.
And in the case where you're reading an old replica or something, you would see that, I guess, at that point. But there'd probably be a flag where the replica would allow you to actually read the object even though it's missing.
Yeah.
In the missing in the OSD definition of it, of missing, or it's just not the latest.
Actually, maybe.
Because you wouldn't want a naive user who's just trying to like read from the closest replica to do that by accident and get a stale version.
Oh no, it should return an error.
Unless you specify a flag that says, I really want to read the stale version.
Yeah, I'm trying to think of a reason why you'd want to do that though.
Because I guess it's not really repair so much as it's like a revert.
It's the
unfound.
repairing the
unfound.
It's the unfound use case. So
yeah,
I guess that's true.
But I think similarly, these are stories for sort of having a robust way to repair unfound objects would be, I actually want to look at the old one and see if it's good enough to roll back to.
That's true. No, I agree. I was just making sure that it's for the it's only for the unfound case. Doing that in the general case though requires you to be able to read from non-acting set replicas also though. The only copy might be an obsolete one on a previous acting set member.
Okay. Well, I think we still just need somebody to do it.
Yep.
David, where are we at with all the? Is David here? Yeah, he's under C. On the Ceph object store tool work. Like, is there? We want to continue. Is there more work to do there, or is this the next?
The next phase is to do if you imported all the EC shards, exported all the EC shards, then you could import them in and recreate the PG.
With EC.
Import with multiple exports.
I see. Do we already have the replicated version where you can import via Redis from an export?
Yeah, you can import with offline OSD or with import Rados.
Rados, okay.
Rados running, yeah.
I see. Okay.
Did that one ever get that one just that's really hard to test in Thrash OSDs. But do we have a sort of a unit testing kind of thing for it?
Yeah.
Cool, excellent. I don't actually think that one's worth implementing in Thrash OSDs. Well, maybe it is. Yes. How would you do it? You'd have to atomically. You'd have to stop all of the OSDs, blast a placement group, start them, and then import, and then force create it, and import Rados.
Yeah,
that would
be
actually.
Good.
Yeah, we can actually do that. Did that make sense? So you wouldn't be able to stop just one OSD or two OSDs because you might get unlucky and peering happens in the meantime. You'd have to actually stop all of the OSDs, identify a healthy copy, export it.
Kill all copies.
Blast them, and then restart all of the OSDs, force create the PG, and then import them. It's actually not that hard, assuming that it works.
Mm-hmm. Yeah, the existing test code is sort of piggybacks on the existing thrashing where it's killing OSDs randomly, and then
in this case, you'd add an additional top-level thrash choosable option, which is test import Rados, which would which would record the currently alive OSDs, kill all of them, rescue one valid copy of the placement group. I guess you have to do it after clean too. That kind of sucks, but that's fine.
Yeah, that'd be okay.
So this would have to be something that happens some percentage of the time after the wait for clean thing. Anyway, and then once you have that, it would be easy to extend to work on a erasure coded pool as well.
Yeah.
Well, easy-ish.
Right.
So I guess how would we what should we do first? Like, is it more useful to have this import multiple
That one's
export
pretty
shards.
useful because it's the only way we have like no way to. Well,
Repair.
I guess we can still transplant the shards, so that's not so bad.
Yeah.
Adding the testing for import Redis is pretty important, and then maybe
and
try to put some time into designing this a little more clearly.
Yeah, I guess I'm thinking that adding
we want this
Thrasher
done sooner. What's that?
I'm thinking that adding the Thrasher support to test the import of a replicated shard or pool, but export whatever your Redis, and then shifting to the grub thing. That makes sense.
Oh, I think that I think the value in the import Redis thing is mostly in being able to do it to an erasure coded pool.
Really?
PG, yeah. Maybe not though.
I mean, right now the transplant is kind of this annoying thing where you rescue a PG from somewhere and then you have to go find some other OSD and stop it and inject it and start it.
True.
It would be nice to just be able to like blast it in.
Okay, I guess so.
On the other hand, the import workflow is kind of scary because you like you blow away all the bad copies and force create PG.
Oh yeah, right. So
like if you have an unhealthy cluster where you have this PG you can't recover.
Well, there are sort of two versions of it. One is that something has happened that has just messed up this PG state. And that's the case where the import Redis one I think is valuable.
Yeah.
But the case where you actually just lost too many OSDs, I'd rather transplant a shard in that case, or the copy in that case.
Yeah. Okay.
Because you strip out all of the offending Redis level metadata by doing, or sub Redis level metadata by doing the import Redis thing.
Yep.
Which is a good workaround.
Yeah, so with the multiple shards thing, that's really to do an import Rados of an EC ECPG when you have enough shards.
Yeah.
Yeah.
You if you don't have enough shards, then you don't have the objects. There's no way to get around that.
Right. But an individual import-export of shards does a lot too, where you might just be repairing a shard or transplanting a shard.
Yeah, I mean this injecting the EC shards via Redis sounds just hugely complicated too, because you have to like read all shards in parallel. Hopefully they order the objects the same, so you actually have all the pieces. You have to do the EC reassembly in the tool and then inject the raw data. That's just
actually even more so. They might have differing missing sets.
Yeah,
that's the really challenging part. Actually, that actually gets really complicated the more I think about it.
Yeah.
Which is more and more likely the more the cluster has been thrashing.
Mm-hmm.
Yeah.
And I mean, without lots of generality, you can always just take the shards that you have and inject them
into one OSD. Actually,
one random OSD. Yeah. Yep. Exactly. Except that the Redis level metadata might have been forked, but we could probably make an option. Probably the simplest thing would just be to make an option that when you're importing the PG, you just sort of like zap all the PG level metadata and just sort of reset it to some simple sane state.
Yeah. Okay, I think you're right. It's probably better to invest the time in the better scrub and repair stuff.
Yeah. Like this, the scrub repair stuff is like a
very important
point, as opposed to a hypothetical repair situation. I think the tools we have right now are getting pretty good.
Okay, so the first step on this one is to write out an actual plan for how the scrub object. For one thing, we need to define inconsistent info T. We need to define what information actually gets written out for each object, where it gets written out, down to how the object is named, and how it interacts with the appropriate Rados read operations. Mostly this isn't too bad because the Rados read operation is going to be a funny looking is going to be a read on a funny looking object, which doesn't give you the actual bytes, but interprets them for you and gives you back a structured output, which is easy. There's machinery in the objector for that. I think RepOp is just better for my money. Anyway.
Yeah.
I don't know if anyone has a different idea on that one, but
Yeah, I mean, the only downside is it's slower, but this is you're
hang
finding
on,
an
there's-
inconsistency, so who cares?
there's another downside. It doesn't work on a Roche coded pool. No OMAPs on a Roche coded pool.
Right. Okay.
Okay, it can be a
Take it
primary
all
local
back.
temp object.
Yep. Yeah, we have to do the again stuff anyway, so I think it's probably fine. I wonder if do we want a PG state bit that like reflects whether or not we know it's inconsistent, but do we also know the information about how it's inconsistent? So you know that you need to rescrub it, basically.
No, because we need to keep more information than that. Maybe the info. Okay, so either in the info or on this thing, or just volatilely in memory, there will be information about the current state of this thing. And as we go through the scrub chunks, we will be updating a set of bounds on which objects we do have inconsistency information on. Remember, the scrub could be stopped partway, or we could perform this scrub. Oh, and that means the interface needs to include information on which objects we have information on.
Well, that means you would. That's so you could do like a partial scrub.
Well, no, so that the output doesn't change in an undefined and weird fashion as scrub continues.
Oh, I see. Yeah.
You want to know that the scrub is in progress and you have information on this, but not that.
Yeah.
Which is very annoying because the user doesn't have an.
I mean, you could just not allow it if scrub's in progress.
Okay, so
right.
if scrub is in progress,
have the whole thing, then. I mean, it could just be a statement that says it's inconsistent, and I have how. I have a complete set of information describing how it's inconsistent.
Well, I mean, it's pretty much.
Internally, we need additional information, like, like which subset of the objects do we have information on. So if it's something other than H object meant to H object, I guess scrub already has that.
That's just a scrub position. Yeah, but you would never, on the repair side or whatever, you never look at that. Like you could just deny any request to query this information if the scrub hasn't completed or is in progress. Or the
I was trying to. I'd want the error codes to indicate either wait longer and I will be done, or I'm not doing a scrub right now. You need to redo the scrub.
Yeah, like E stale or E in progress.
Those should be different. Yeah. E stale versus E again.
Rescrub or E in progress. Scrub in progress.
Or E in progress? Oh yeah, let's do that then.
Yeah.
Of course, that inconsistent information is stale the minute it's created, but I mean,
only in one kind of sense.
Objects can get removed. New inconsistent objects could be
the information needs to be maintained as objects are.
Yeah, like on a per. That means that this inconsistent
can't be maintained in memory, by the way.
Well, no, why bother? Like if an inconsistent object's removed, I mean, if some tool says, "Hey, repair this," and it's not there, then it's like, "Oh, well, it's not there. It was inconsistent when we scrubbed when it existed. It's not there now." Oh, yeah, as long as there's versioning.
Inconsistent object T thing should have a version, so we know which version of the object it was, and if it's updated, then we sort of don't know anymore.
Right.
That's valid.
And then you get an E stale for that individual object, probably.
I really want to be able to rescrub a single object for Rados.
That's on here.
Yeah, that's hard.
Per scrub operation.
Yeah. No, I mean that's one of the ones we need a fair amount of refactoring for.
Yeah.
A lot for that.
Yeah. Right. Well, when you repair a specific object that was inconsistent the last time it was scrubbed, I mean, it obviously you would rescrub it and repair it, right?
Yeah. No. Yeah. The catch is that the scrub stuff needs to be refactored in such a way that it can be invoked from Librados in a way that gives back completion information in a Librados valid fashion, and also from the scrub process. it needs to be the same mechanism, or one's going to work and one doesn't. So you're right. It's not conceptually complicated, but it's code complicated.
Mm.
It's boringly complicated.
So is the what actual metadata do you want to store? I mean, for every is it a map of shard to like the type of error, whether it's missing or EIO or
Okay,
something like that?
so which
does it
things
even
make
matter?
sense to the client? So the version makes sense to the client. So let's say the object infos don't agree. Let's distill down which things should be propagated to the client. So for each shard, the version certainly should be. The size should be. The checksum should be. That one's easy. No, I think the actual checksum should be sent. So like there could be like a known error thing. So like if it's just not there, then okay, so this error field would say missing shard or missing checksum if we know the checksum to be wrong because it's an erasure coded object or because it's a replicated object and it doesn't agree with the full object digest. But let's say everyone is there, we don't have a full object digest, and they didn't return EIO, but they don't agree. Then each one we should actually return the version, should we return the set of adders they do have? Nah, let's not do that. Maybe, well, if the object info isn't present, then we know that that's practically an EIO. I think. If any of the like OSD specific metadata is missing from a shard, I think that's an EIO.
Okay.
But so eversion, T version, went 32 checksum in case it's actually valid.
Say like you want to I would do bad metadata.
Yeah, bad metadata is fine. I just mean that
from bad disk.
OSD says there's
bad medium.
Oh, it could very well be a bad disk. That's what bothers me about it. Well, maybe not.
Medium.
I don't know.
But
I can't think of another way you'd
know.
be missing an X header. Yeah, that's true. Okay. So
medium or bad metadata.
bad medium. So bad medium means specifically the file system told us something is off here. Okay, that makes sense. I don't think we should ever repair. We should always rewrite.
Yeah, right.
Because one could path is simpler than two.
Oh, error T error.
Yeah, right. Is there any other information you would want to know? Size. Size T size. Or it can't be a size T. UN64 T size. I don't think we should actually send back the adders. They could be big. Well, I guess they can't be big. Not unless you're misusing the interface. Okay.
I mean, if we don't have the adders, then we need to have an adder digest. But currently, we never do that because we just deal with the adders explicitly.
Yeah, you're right.
I might as well just put them in there. Yeah. I mean, this is basically what Scrub is doing, comparing.
It should be user translated adders, by the way. So we remove the underscore and we filter out the OSD specific adders. And buffer pointer or buffer list? I kind of want to remove buffer pointer from that interface altogether.
Oh, yeah, sure. That's annoying.
So we winding this one down, are we?
Yeah. Error T. So this is and this would go in temp object on primary in OMAP, and probably Maybe on, it could go on the PG info object with every other piece of PG metadata.
This could be big. It could be proportional to the number of objects. I think it should be in its own object.
Oh, it can go in that. It can go in the temp collection. It can go in the PG temp namespace.
Yeah,
Really is temporary.
that makes
Most
sense.
of the way. Okay, cool.
I'm kind of wondering whether that should be OMAP entries or something else.
I mean, we could just append, but I think OMAP entries means it's queryable, which seems good.
The thing is, the only interface, well, the problem is deleting an object with OMAP entries is linear in the number of OMAP entries.
Yep.
I guess that's okay.
Yeah, I mean, if we want to make that fast, it's deleting anything is always linear. I guess it's not. You can just you update the
no,
allocation
it's not.
bitmap.
For a file system, you just unallocate it.
But it could be, because it could, if it were fragmented. But the file system hides it from you, right? So the
No, I mean, that and the
also
file
hide it from
system goes to some effort to arrange for it to be asymptotically better than that, right?
usually.
And, well, I guess not. Still, if it's still linear, it's a massively different ballpark of pain.
Yep.
If LevelDB had the ability to remove a range of keys, then it could do it efficiently, but it doesn't.
That would be nice. Like a mega whiteout or whatever. Anyway, okay. That's probably enough to go on.
Yeah.
Now. All right, so plan of record, finish Redis, import of a PG export with testing, and then shift to this. And probably we need to fix well, we'll probably start by storing the scrub state.
Yeah.
But we'll also need to fix the read from replica stuff at some point in parallel.
That's one of the things I was going to do early, because I need it for, I can't remember, but something else.
Everything needs it, I think.
There was some chain of tasks with that at the bottom, and I can't remember what it was.
Okay. All right. Cool.
Oh yeah, it was for making peering faster. I needed to be able to keep object contexts across intervals. Yeah. That was it. To fix the delete thing on the cluster. Right.
Yep. Okay. All right. Should we move to the next one?
All right.
This one wasn't me. Who knows what this one was about? Okay.